fact, this geoengineering idea in its simplest form is basically the following. You could put fine particles, say sulfuric acid particles, sulfates, into the upper atmosphere, the stratosphere, where they'd reflect away sunlight and cool the planet. There's lots of mystery in the details, and there's some bad side effects, like it partially destroys the ozone layer, and I'll get to that in a minute, but it clearly cools down. And one other thing, it's fast. I guess the thing I haven't said about this is it is absurdly cheap. It's amazing how we can affect the planet. The one thing about this is it gives us extraordinary leverage. This improved science and engineering will, whether we like it or not, give us more and more leverage to affect the planet, to control the planet, to give us weather and climate control, not because we plan it, not because we want it, just because science delivers it to us bit by bit.
What is geoengineering?
It's really two very different things. One is ways that we would alter the amount of sunlight the Earth absorbs, and so cool the planet, partly offsetting the effects of carbon in the atmosphere, and that's called solar radiation management, or in some technocratic way, SRM. And the other one is to take carbon out of the atmosphere, so-called carbon dioxide removal.
Before we get on to solar radiation management, let me ask you about the carbon dioxide removal. A Royal Society report here in the United Kingdom back in 2009 said that no method of carbon dioxide removal has yet been demonstrated to be effective at an affordable cost with acceptable environmental impacts, and they only work to reduce temperatures over very long timescales.
I think that's exactly right, and I can say that both as an author of that report and as somebody running a startup company trying to capture CO2 from the air.
Before we get into the pros and cons of it, how solar radiation management might work.
Conceptually, it's simple. The doing it is not the hard part, but you could use aircraft or other methods to deliver literally tons or millions of tons of very small reflective aerosols, tiny particles, say, to the upper atmosphere.
Spraying them out at a high altitude.
Correct.
Isn't one of the problems with the climate and studying the climate is that it's incredibly difficult to know exactly how it works. It is very difficult to model.
Sure, it's impossible to know exactly, but you can still learn a lot. So we actually ran a survey almost a year ago now that took data, high-quality data, from 1,000 people in the UK, Canada, and the US to try and understand public support for research on these technologies and what kind of political leanings influence people's decision to be for or against. And in fact, we found pretty broad support for research.
But that particular opinion survey that you're talking about, it also came up with the finding that 64% of subjects agree that humans should not be manipulating nature in the way suggested by solar radiation management.
Exactly.
Well, that would suggest that there isn't particularly broad support at the moment for the theory behind this.
There's not broad support for doing it, and I think that's quite a healthy thing. I mean, I'm one of the people who, maybe starting 20 years ago, most helped to open the door to get public conversation going on this thing.
How do you think, in that case, the public can be convinced, given that there is, as we saw with this project in Britain, tremendous skepticism even about research at what you say is a very, very benign level?
Public opinion will evolve over a long time, and from my point of view, the goal is to try and make that public opinion be able to be shaped by facts as well as possible, and also shaped by people's values. It's not to promote this. So actually...
well, it is in part to promote this. I mean, you're a great enthusiast for this, and as you said, you have your own private company, which is...
my private company works on a very different part of it, which doesn't suffer from these governance challenges.
But it is all to do with the issue of geoengineering.
Actually,
I mean, it's an incredibly sensitive topic.
I actually don't think my job is promoted. My job is to help clear thinking and clear knowledge about the tools we have to regulate climate risk, among them this one. And I'm perfectly prepared to find that results show that we should never do this. So if it works, and again, we don't know it does, it provides some protection in the near term.
Isn't there a problem, though, that you could end up with different effects in different parts of the world? I mean, you could, for example, find that although you're reducing the amount of sunlight and the amount, therefore, that the Earth is warming up, rainfall is affected in different ways in different parts of the world.
Absolutely. Essentially, the scientists and technocrats, including myself, I guess, are helping to invent a thermostat knob. But it's much easier to invent the knob than to figure out who should be in charge of it in a world with many states.
No, indeed, and I want to come on to the governance, but I want to ask specifically about the science of this, which is how far can you tell whether the effects of solar radiation management are then going to cause perhaps a catastrophic loss of rainfall in a certain part of the world. At the moment, it seems to be hazy, this.
I think it's not as hazy as that. So using exactly the same climate models as we've used to estimate the problems with CO2 in the atmosphere, the underlying climate problem, we've applied those same models and same techniques to look at this. And the results so far, I have to say, look pretty good. That's why we're paying any attention to it.
Richard Branson himself, who owns the Virgin Airline Group, was quoted back in 2009 in the New York Times saying, if we could come up with a geoengineering answer to this problem, we could carry on flying our planes and driving our cars.
It's going to cost a lot of money.
And yet I mean, let's be clear here, you and your company are after Branson's money.
The cheapest thing to do is to use the atmosphere as a waste dump. And if we want to stop doing that, we must have laws that restrict the ability to use the atmosphere as a waste dump.
My question is, are you not concerned that you and your company, Carbon Engineering, is looking for money from people like Richard Branson? It's funded, I think, in part by Murray Edwards, who is a key figure in tar sands, which is seen as one of the dirtiest fuels on the planet.
It is.
Are you not slightly concerned about the people who you're getting into bed with?
I'm happy to take money from serious folks who have a broad set of interests. No problem. First of all, I should say, for work on SRM, on these very high leverage technologies that have security concerns, I believe there should be no private action, there should be no for-profit action. I believe it would make sense for SRM to actually restrict or eliminate the possibility of patenting.
Isn't your company involved in several patents at the moment?
This is the difference. So for capturing CO2 from the air, that's an encapsulated small technology, which can be regulated by the normal laws. It's inherently expensive, so there's no risk of sucking all the CO2 out of the air because it costs so much. Any technology you have that removes CO2 will have local risks, maybe unacceptable risks, but those risks can be managed by the normal local risk management we have. So I think that I'm happy to see private action on cutting emissions by making solar power or electric vehicles or capture from air. I'm not happy to see public action on technologies with this huge leverage, like putting particles in the stratosphere.
I'll tell you a little bit about some new work we've been doing, thinking about how you actually might put aerosols in the stratosphere. The novel method we've been thinking about, or it's not novel at all, it's actually exactly what happens from aircraft contrails, is that we put a condensable, a few megatons a year of sulfur would be enough to produce sort of 4 watts per square meter radiative forcing directly out of the back of an aircraft. There's a huge literature in the nanofabrication world about making fine particles from low vapor pressure gas, and there's nothing very hard in terms of aircraft engineering. If you go to aircraft engineers, and we've done this, they say, that would be easy, we could do this if you want us to. We've mostly thought about sulfur, and there's a lot of good reasons to think about sulfur, because sulfur's what nature does, at least in this version of the model, is if you put sulfur in continuously, you actually get a remarkably ineffective result. Nevertheless, there might be some good reasons to think about alumina. The big deal really is that alumina has 4 times the volumetric rate as sulfur, but roughly 16 times less the coagulation rate. So you could get away, we think, with much smaller mass flux. The little picture is from a nanofabrication study, which shows you can make high-quality alumina particles just by spraying alumina vapor out, which oxidizes. So it certainly seems pretty cost-effective and easy to do this with aircraft that are not very different from conventional aircraft. High-class business jets like the Gulfstream have wing designs that are very efficient. So with slightly different engine choices, they can easily deliver large weights up to sort of 20 kilometers or a little higher. And you could do that by either building new versions of these aircraft or even re-engineering existing aircraft. We have engineering firms that can do it. So you go to an engineering firm and you want this done. They don't say this is hard or unusual. They say, okay, yes, we could do it. Once you realize you can make things by direct condensation from vapor, then all sorts of different compounds are possible. But it's much, much harder to actually figure out the environmental risks and effectiveness of these new methods than it is to cook them up. Aerosol geoengineering looks like it is so cheap that the cost is basically not going to be an issue. That means that implementation decisions will be risk-to-risk decisions. So the key factors are this is fast, it's cheap, and it's inherently imperfect. It cannot compensate for the amount of CO2 in the air. On a commercial basis, I do absolutely no proprietary commercial work on solar radiation management because I think such work would be wrong.
Solar geoengineering refers to a set of technologies that could allow humanity to deliberately increase the planet's reflectivity, and so partially offsetting the temperature changes and other climate changes that come from the accumulation of carbon dioxide. Solar geoengineering can be very inexpensive. The cost might be something like $10 billion for the whole planet. That sounds like a lot of money each year, but in fact that's something like 1/10,000th of global GDP.